the stream should be kicking back in any second now. Yep, okay, cool. So what we're going to do is we're going to keep working through the introduction to Emacs Lisp, the Emacs Lisp introduction, or however people say it. So before we start on practicing evaluation, we're going to go over my notes, some of the questions we had, some of the questions we solved. So the single apostrophe before a list causes that list to return. Without the single apostrophe, the first element of the list will be treated as a command. For some reason, evaluating the innermost symbolic expressions gives 2 twice. So this was a issue I was having where if I evaluated this, it would give me 2, and then if it evaluated this, it would give me 2. And that was because if the cursor is directly after a number evaluates to itself. So two-faced symbols, so this was where I was trying to figure out how it works that you can have a symbol that links to a value as well as a function, and it seems to be to do with the way you evaluate your lists. So if you have one of those lists without an apostrophe in front of it, then the first atom in the list will be evaluated as a command. Otherwise it won't be. It'll be evaluated as a value, I think. Single apostrophe and listless symbols. So just as a single apostrophe in front of a list returns the list, so too does a single apostrophe before a symbol return the symbol. So rather than evaluating the function of the symbol or something, it just returns the symbol itself directly. Markers are considered similar to numbers, so this is a data type, specifically the number of characters from the beginning of the buffer. Functions which contain a p at the end for predicate are used to test whether their argument is a certain type of value. So what is the difference between set and set q? In set, the first argument is evaluated unless it has a quote before it. In set q, the argument is automatically quoted. Set q can also take multiple arguments. There you go. Okay, practicing evaluation. So before learning how to write a function definition in Emacs Lisp, it is useful to spend a little time evaluating various expressions that have already been written. These expressions will be lists with the functions as their first and often only element. Since some of the functions associated with buffers are both simple and interesting, we will start with those. In this section, we will evaluate a few of these. In another section, we will study the code of several other buffer-related functions to see how they are written. So, I'm going to pause us there. And I'm just going to quickly look up how to save a window layout to a registry. I can't remember how to. I don't do that often, but I want to preserve this and then change the layout. So Control X, R, W, and I'll save this as I for introduction, and then I'm going to go here and we're going to find the file software exorcism. That's not what I want. Exorcism, eLisp, hello world. I'm going to open that. Then over here, here we're gonna do the same. We're gonna open up the test file, so just so we can keep in mind what's in there. And then finally we're gonna make this an eShell buffer, and we're gonna save this to the registry as E for exorcism. So now if I press Control X R J and then I say I, we go back to that, Control X R J E, we go back to this. Cool. So now what I want to do, so provide hello world, so provide the symbol hello world. So I want to define a function. I don't know how to define a function yet. Okay, so we'll do this later then. Control X R I. Nope, that's not what I want either. Control X R J I. Yeah, bit clunky. Alright, practicing evaluation. Before learning how to write a function okay, so we're going to learn it pretty soon after this chapter. So, before learning how to write a function definition in Emacs Lisp, it is useful to spend a little time. Let me just check on the stream, make sure it's not a complete disaster. Still don't know how to change the tags. Advanced settings? I really don't know. Anyway, doesn't matter. These expressions will be lists with the functions as their first and often only element. Since some of the functions associated with buffers are both simple and interesting, we will start with those. In this section we will evaluate a few of these. In another section we will study the code of several other buffer related functions to see how they were written. Okay. Mark set. Why is it set a mark? Anyway. How to evaluate. Whenever you give an editing command to Emacs Lisp, such as the command to move the cursor or to scroll the screen, you are evaluating an expression, the first element of which is a function. This is how Emacs works. When you type keys, you cause the Lisp interpreter to evaluate an expression, and that is how you get your results. Even typing plain text involves evaluating an Emacs Lisp function. In this case, one that uses self-insert command, which simply inserts the character you typed. The functions you evaluate by typing keystrokes are called interactive functions or commands. How you make a function interactive will be illustrated in the chapter on how to write function definitions. See making a function interactive. In addition to typing keyboard commands, we have seen a second way to evaluate an expression. So here, I got a question right away. What is the difference between an interactive and normal function? In addition to typing keyboard commands, we've seen a second way to evaluate an expression by positioning the cursor after a list and typing Control X, Control E. This is what we will do in the rest of this section. There are other ways to evaluate an expression as well. These will be described as we come to them. Besides being used for practicing evaluation, functions shown in the next few sections are important in their own right. A study of these functions makes clear the distinction between buffers and files, how to switch to a buffer, and how to determine the location with them. Okay. Buffer name. The two functions buffer name and buffer file name show the difference between a file and a buffer. When you evaluate the following expression, buffer name, the name of the buffer appears in the echo area. Let's see if we can evaluate it when it's between quotes like that. Yes, we can. So it's giving me info. Now what about nil. So there's no file, apparently, linked to this buffer. The name of the file to which the buffer refers appears in the echo area. Usually the name returned by buffer name is the same as the name of the file to which it refers, and the name returned by buffer file name is the full path file. A file and a buffer are two different entities. So this is talking about a buffer. A buffer is like this area here. Well, not exactly. That's technically a window, and a window shows you a buffer. And a buffer is like a memory region that holds some data, usually the contents of a file. So this is a buffer, but there's no file attached to it, and then I'm viewing the buffer through a window. A file and a buffer are two different entities. A file is information recorded permanently in the computer unless you delete it. A buffer, on the other hand, is information inside of Emacs that will vanish at the end of the editing session, or when you kill the buffer. Usually a buffer contains information that you have copied from a file. We say the buffer is visiting that file. This copy is what you work on and modify. Changes to the buffer do not change the file until you save the buffer. When you save the buffer is copied to the file and is thus saved permanently. If you're reading this in info inside GNU Emacs, you can evaluate each of the following expressions by positioning the cursor after it and typing Ctrl-X, Ctrl-E. We've already done that, so we don't need to do it again. When I do this in info, the value returned by evaluating buffer name is #info#, and the value returned by evaluating buffer file name is nil. On the other hand, while I am writing this document, the value returned by evaluating buffer name is introduction.textinfo, and the value returned by evaluating buffer file name is gnu/work/intro/introduction.textinfo. Okay. The former is the name of the buffer and the latter is the name of the file. In info, the buffer name is info. Info does not point to any file, so the result of evaluating buffer file name is nil. The symbol nil is from the Latin word for nothing. In this case, it means that the buffer is not associated with any file. In Lisp, nil is also used to mean false and is a synonym for the empty list. Okay. When I am writing, the name of my buffer is introduction.textinfo. The name of the file to which it points is /GNU/work/intro/introduction.textinfo. In the expressions, the parentheses tell the Lisp interpreter to treat buffer name and buffer file name as functions. In the expressions, the parentheses tell the Lisp interpreter to treat buffer name and buffer file name as functions. Without the parentheses, the interpreter would attempt to evaluate the symbols as variables. See variables. What does happen when I void variable? Okay. Whoops. What did I just do? Okay. In spite of the distinction between files and buffers, you will often find that people refer to a file when they mean a buffer and vice versa. Indeed, most people say I'm editing a file rather than saying I am editing a buffer, which I will soon save to a file. It is almost always clear from context what people mean. When dealing with computer programs, however, it is important to keep the distinction in mind since the computer is not as smart as a person. The word buffer, by the way, comes from the meaning of the word as a cushion that deadens the force of a collision. In early computers, a buffer cushioned the interaction between files and the computer's central processing unit. Drums or tapes that held a file and the central processing unit were pieces of equipment that were very different from each other, working at their own speeds in spurts. The buffer made it possible for them to work together effectively. Eventually, the buffer grew from being an intermediary, a temporary holding place, to being the place where work is done. This transformation is rather like that of a small seaport that grew into a great city. Once it was merely the place where cargo was warehoused temporarily before being loaded onto ships. Then it became a business and cultural center in its own right. So not all the buffers are associated with files. For example, a scratch buffer does not visit any file. Similarly, a help buffer is not associated with any file. In the old days, when you lacked a home/.emacs file and started an Emacs session by typing the commands Emacs alone without naming any files, Emacs started with the scratch buffer visible. Nowadays, you will see a splash screen. You can follow one of the commands suggested on the splash screen, visit a file, or press the spacebar to reach the scratch buffer. I didn't know that. I guess it defaults to being on the scratch buffer selection. If you switch to the scratch buffer, type buffer name, position the cursor after it, and then type Ctrl+X, Ctrl+E to evaluate the expression, the name scratch will be returned and will appear in the echo area. Scratch is the name of the buffer. When you type buffer file name in the scratch buffer and evaluate that, nil will appear in the echo area, just as it does when you evaluate buffer file name in info. Incidentally, if you are in the scratch buffer and want the value returned by an expression to appear in the scratch buffer itself, rather than in the echo area, type Ctrl+U, Ctrl+X, Ctrl+E instead of Ctrl+X, Ctrl+E. This causes the value returned to appear after the expression. The buffer will look like this. Hey, let's try that out. So, X, Ctrl+E, cool. Then if I press Control, what was it? Ctrl+U, Ctrl+X, Ctrl+E. What happens if I evaluate that? Interesting. Wonder what function that serves. Cannot do this in info since info is read-only and it will not allow you to change the contents of the buffer. But you can do this in any buffer you can edit. And when you write code or documentation such as this book, this feature is very useful. So I guess, yeah, it's good for writing if you don't want to write in org. Okay, getting buffers. The buffer name function returns the name of the buffer. To get the buffer itself, oh, that's interesting. Okay, a different function is needed. The current buffer function. If you use this function in code, what you get is the buffer itself. So this, I guess by that it means the symbol of the buffer. So a name and the object or entity to which the name refers are different from each other. You are not your name, you are a person to whom others refer by name. If you ask to speak to George and someone hands you a card with the letters G, E, O, R, G and E written on it, you might be amused, but you would not be satisfied. You do not want to speak to the name, but to the person to whom the name refers. A buffer is similar. The name of the scratch buffer is scratch, but the name is not the buffer. To get a buffer itself, you need to use a function such as current buffer. However, there is a slight complication. If you evaluate current buffer and expression on its own, as we will do here, what you see is a printed representation of the name of the buffer without the contents of the buffer. Emacs works this way for two reasons. The buffer may be thousands of lines long, too long to be conveniently displayed, and another buffer may have the same context but a different name, and it is important to distinguish between them. Okay, here is an expression containing the function current buffer. So, hash buffer info. Okay, if you evaluate this expression in info in Emacs in the usual way, buffer info will appear in the echo area. The special format indicates that the buffer itself is being returned rather than just its name. Okay, interesting. So, hash buffer hash buffer name. A special format that indicates the buffer itself is being returned as opposed to the name of the buffer. Incidentally, while you can type a number or symbol into a program, you cannot do this with the printed representation of a buffer. The only way to get a buffer itself is with a function such as current buffer. A related function is other buffer. This returns the most recently selected buffer other than the one you are in currently, not a printed representation of its name. If you have recently switched back and forth from the scratch buffer, other buffer will return that buffer. You can see this by evaluating the expression other buffer. Buffer hello world.ear. Yep. You should see buffer scratch appear in the echo area or the name of whatever other buffer you switched back from most recently. Okay, the footnotes. Actually, by default, if the buffer from which you just switched is visible to you in another window, other buffer will choose the most recent buffer that you cannot see. This is a subtlety that I often forget. What? Actually, by default, if the buffer from which you just switched is visible to you in another window, other buffer will choose the most recent buffer that you cannot see. Oh, and that's why it returned hello world.el. That makes sense. Oh, how long have I been going? 20 minutes. Not even close to the amount of time I was hoping to go. I don't know why I'm so tired today. I guess the heat's getting to me. Switching buffers. The other buffer function actually provides a buffer when it is used as an argument to a function that requires one. We can see this by using other buffer and switch to buffer to switch to a different buffer. But first, a brief introduction to the switch to buffer function. When you switch back and forth from info to the scratch buffer to evaluate buffer name, you most likely typed Ctrl+X+B and then typed scratch when prompted in the mini buffer for the name of the buffer to which you wanted to switch. The keystrokes Ctrl+X+B cause Lisp interpreter to evaluate the interactive function switch to buffer. As we said before, this is how Emacs works. Different keystrokes call or run different functions. For example, Ctrl+F calls forward char, meta E calls forward sentence, and so on. By writing switch to buffer in an expression and giving it a buffer to switch to, we can switch buffers just the way Ctrl+X+B does. Switch to buffer, other buffer. So I'm going to try that out. Switch to buffer, and I'm going to switch it to yeah, let's just try other buffer for now, because I don't know how to get a... Yep, cool. But then I'm gonna go back to scratch. What does that return? Switch to buffer, other buffer, Ctrl+U+X+E. It returns the buffer that you switched to. Okay. The symbol switch to buffer is the first element of the list, so the Lisp interpreter will treat it as a function and carry out the instructions that are attached to it. But before doing that, the interpreter will note that other buffer is inside parentheses and work on that symbol first. Other buffer is the first, and in this case the only element of this list, so the Lisp interpreter calls or runs the function. Hang on, let me try something. Okay, so we're going to see if I can just input this to switch to buffer and have it work. Yeah, I didn't think so. Maybe if I pre-quote it. No. Okay. What if I put it inside a list, but it's a quoted list? Let's see what that evaluates to. Actually, I really didn't like that. What if I put it in quotation marks? Oops. Yeah, I can't do that. Interesting. So that interesting. Okay, I'm going to kill that buffer. I'm going to switch back to scratch buffer. And my next question is, how do I feed a buffer name directly into switch to buffer? Anyway, continuing on. So where was I? So in the programming examples in later sections of this document, you will see the function set buffer more often than switch to buffer. This is because of a difference between computer programs and humans. Humans have eyes and expect to see the buffer on which they are working on their computer terminals. This is so obvious it almost goes without saying. However, programs do not have eyes. When a computer program works on a buffer, that buffer does not need to be visible on the screen. Switch to buffer is designed for humans and does two things. It switches the buffer to which Emacs attention is directed, and it switches the buffer displayed in the window to the new buffer. Set buffer, on the other hand, does only one thing. It switches the attention of the computer program to a different buffer. The buffer on the screen remains unchanged. Of course, normally nothing happens there until the command finishes running. Also, we have just introduced another jargon term, the word call. When you evaluate a list in which the first symbol is a function, you are calling that function. The use of the term comes from the notion of the function as an entity that can do something for you if you call it, just as a plumber is an entity who can fix a leak if you call him or her. So footnotes. Or rather, to save typing, you probably only typed return if the default buffer was scratch, or if it was different, then you typed just a small part of the name, such as *SC, pressed your tab key to cause it to expand to the full name, and then type return. Remember, this expression will move you to your most recent other buffer that you cannot see. If you really want to go to your most recently selected buffer, even if you can still see it, you need to evaluate the following more complex expression. Switch to buffer, other buffer, current buffer, true. In this case, the first argument to other buffer tells it which buffer to skip, the current one. And the second argument tells other buffer it is okay to switch to a visible buffer. Okay. In regular use, switch to buffer takes you to a buffer not visible in Windows, since you would most likely use Ctrl+X+O other window to go to another visible buffer. buffer size and the location of point. Finally, let's look at several rather simple functions. Buffer size, point, point min, and point max. These give information about the size of a buffer and the location of point within it. The function buffer size tells you the size of the current buffer. That is, the function returns a count of the number of characters in the buffer. Function buffer size tells you the size of the current buffer. That is, the function returns a count of the number of characters in the buffer. You can evaluate this in the usual way. Oops. Don't know what I pressed, but okay, so apparently there is 746,748 characters, so I'm guessing that includes the whole book, which is kind of interesting. You can evaluate this in the usual way by positioning the cursor after the expression and typing Ctrl-X, Ctrl-E. In Emacs, the current position of the cursor is called point. The expression point returns a number that tells you where the cursor is located as a point of the number of characters from the beginning of the buffer up to point. Right. You can see the character count for point in this buffer by evaluating the following expression in the usual way. Okay, so I got a number. Okay, as I write this, the value of point is 65,724. The point function is frequently used in some of the examples later in this book. The value of point depends, of course, on its location within the buffer. If you evaluate point in this spot, the number will be larger. Okay. For me, the value of point in this location is 66043, which means that there are 319 characters, including spaces, between the two expressions. Doubtless you will see different numbers since I will have edited this since I first evaluated point. Function point min is somewhat similar to point, but it returns the value of the minimum permissible value of point in the current buffer. This is the number 1 unless narrowing is in effect. Narrowing is a mechanism whereby you can restrict yourself or a program to operations on just part of a buffer. Likewise, the function point max returns the value of the maximum permissible value of the point. So because we're in info and it kind of displays the document weird, I wonder if this will give us one. Void variable. Oh, I see. Well, I'll just evaluate it. So, point min. Ah, yeah, okay. So this is using narrowing to display the buffer. Interesting. Exercise. Find a file with which you are working and move towards its middle. Find its buffer name, file name, length, and your position in the file. Okay. Well, let's just use our notes.org. So, find a file with which you are working and move towards its middle. Okay. Let's try and get really funky. Forward. So I need to find out how this takes arguments. So Control H, K, Control F. So forward char optional number. Move point n characters forward. Backward is n is negative. On reaching end or beginning a buffer, stop and signal error. Interactively, n is the numeric prefix argument. If n is omitted or nil, move point 1 character forward. Depending on the bidirectional context, movement may be to the right or to the left of the screen. This is in contrast with right. Okay. So we can feed, so forward char, and then we want to evaluate the length, because we want to move to the middle. So we want to get the length of the document. So how did we do that again? What was that? What was the argument for that? We had to get the I'm going to Google it. Get number of characters in current buffer Emacs. No, we can just use point max. Yep. And then we want to put that inside a division. So divide. I think I can use that. Yep, divisors. Cool. Point max by 2, and then that should get me to the middle character of the buffer. Let's scroll, and yeah, we're almost halfway through the document. Of course, it's not going by lines, it's going by characters, so we're not going to end up exactly in the middle of the document. We're at the middle character of the document. So let's run that again. Okay, that's not quite right. So how do I just move the point? It's Google moving point. Move forward, move backward, down, up, meta forward, move backward, move to the end of the buffer, and move point to buffer position N. Meta GC, position 1 is the beginning of the buffer. Okay. So first I need to do Control H, K, meta GC, and that links to go to char position. So go again, go to char. It should end up on that end no matter where in the document we run this from. Yep. Yep, cool. So find a file with which you're working and move towards its middle. Find its buffer name. So now we're going to get its buffer name. Current buffer, its length, point max 2017, and I think we can just evaluate point, right? Yes, 1008. Cool. 1008 should be half of whatever point max is. So it should be 2016. It's nearly 2017, but that's odd, so that makes sense. Okay, we're ready. We're ready to learn how to write function definitions. Great excitement. One moment, guys. Just gonna attend. Hey guys, I just grabbed myself a quick snack to prepare myself for writing function definitions. This is exciting. So, actually I might just finish this snack first.
Modification to that. So basically,
Alright guys, so that took about 10 minutes. I'm just trying to drink as much water as I can. It's so warm here, it just feels like I just can't drink enough water to keep up. Alright. When the Lisp interpreter evaluates a list, it looks to see whether the first symbol on the list has a function definition attached to it, or put another way, whether the symbol points to a function definition. If it does, the computer carries out the instructions in the definition. A symbol that has a function definition is called simply a function, although properly speaking the definition is the function and the symbol refers to it. I need to get some ice blocks or something, I'm too hot. Hopefully this will keep me cool, or at least help a little bit. An aside about primitive functions. All functions are defined in terms of other functions, except for a few primitive functions that are written in the C programming language. When you write functions definitions, you will write them in Emacs Lisp and use other functions as your building block. Some of the functions you will use will themselves be written in Emacs Lisp, perhaps by you, and some will be primitives written in C. Primitive functions are used exactly like those written in Emacs Lisp and behave like them. They are written in C so we can easily run GNU Emacs on any computer that has sufficient power and can run C. Let me re-emphasize this. When you write code in Emacs Lisp, you do not distinguish between the use of functions written in C and the use of functions written in Emacs Lisp. The difference is irrelevant. I mention the distinction only because it is interesting to know. Indeed, unless you investigate, you won't know whether an already written function is written in Emacs Lisp or C. Okay. In Lisp, a symbol such as mark whole buffer has code attached to it. It tells the computer what to do when the function is called. This code is called the function definition and is created by evaluating a Lisp expression that starts with the symbol defun, which is an abbreviation of define function. Okay. In subsequent sections, we will look at function definitions from the Emacs source code, such as mark whole buffer. In this section, we will describe a simple function definition so you can see how it looks. This function definition uses arithmetic because it makes for a simple example. Some people dislike examples using arithmetic. However, if you are such a person, do not despair. Hardly any of the code we will study in the remainder of this introduction involves arithmetic or mathematics. The examples mostly involve text in one way or another. So a function definition has up to 5 parts following the word defun. The name of the symbol to which the function definition should be attached. A list of the arguments that will be passed to the function. If no arguments will be passed to the function, this is an empty list. Documentation describing the function. Technically optional but strongly recommended. Optionally, an expression to make the function interactive so you can use it by typing metax, and then the name of the function, or by typing an appropriate key or keycord. So is that saying there that you have to make a function interactive to be able to invoke it with metax? Or a keycord? Okay. Well, see, now that's interesting. What's going on here? So an interactive function is one which can be invoked directly. For example, touch typing with a icy pole in my hand is not the easiest thing. For example, through metax or a keyboard shortcut. Code that instructs the computer what to do, the body of the function definition. It is helpful to think of the 5 parts of a function definition as being organized in a template with slots for each. Defun, function name, a list of arguments, optional documentation, between quotation marks, interactive argument passing info, interactive argument passing info, which is optional, body. Oh yeah, I see, okay. As an example, here is the code for a function that multiplies its argument by 7. This example is not interactive. Defun, multiply by 7. Number, multiply number by 7. Times 7 number. I apologize to anybody listening to this. Unless they like it. Unless it's sort of like ASMR, I guess. This definition begins with a parenthesis and the symbol defun, followed by the name of the function. The name of the function is followed by a list that contains the arguments that will be passed to the function. This list is called the argument list. In this example, the list has only one element, the symbol number. When the function is used, the symbol will be bound to the value that is used as the argument to the function. Instead of choosing the word number for the name of the argument, I could have picked any other name. For example, I could have chosen the word multiplicand. I picked the word number because it tells what kind of value is intended for this slot. But I could just as well have chosen the number multiplicand to indicate the role that the value placed in this slot will play in the workings of the function. I could have called it fugal but that would have been a bad choice because it would not tell humans what it means. The choice of name is up to the programmer and should be chosen to make the meaning of the function clear. Indeed, you can choose any name you wish for a symbol in an argument list, even the name of a symbol used in some other function. The name you use in an argument list is private, so that particular definition, in that definition, the name refers to a different entity than any use of the same name outside the function definition. Suppose you have a nickname Shorty in your family. When your family members refer to Shorty, they mean you, but outside your family, in a movie for example, the name Shorty refers to someone else. Because a name in an argument list is private to the function definition, you can change the value of such a symbol inside the body of a function without changing its value outside the function. The effect is similar to that produced by a let expression. So we haven't done let yet, so I'm not sure what it means by that. The argument list is followed by the documentation string that describes the function. This is what you see when you type Control-H, F, and the name of a function. Incidentally, when you write a documentation string like this, you should make the first line a complete sentence, since some commands, such as apropos, print only the first line of a multi-line documentation string. Also, you should not indent the second line of a documentation string, if you have one, because that looks odd when you use Control-H-F, describe function. The documentation string is optional, but it is so useful. It should be included in almost every function you write. The third line of the example consists of the body of the function definition. Most function definitions, of course, are longer than this. In this function, the body is the list times 7 number, which says to multiply the value of number by 7. In Emacs Lisp, times is the function for multiplication, just as plus is the function for addition. When you use the multiply by 7 function, the argument number evaluates to the actual number you want used. Here is an example that shows how multiply by 7 is used, but don't try to evaluate this yet. Multiply by 7, 3. The symbol number specified in the function definition in the next section is bound to the value 3 in the actual use of the function. Note that although number was inside parentheses in the function definition, the argument passed to the multiply by 7 function is not in parentheses. The parentheses are written in the function definition so the computer can figure out where the argument list ends and the rest of the function definition begins. If you evaluate this example, you are likely to get an error message. Go ahead, try it. This is because we have written the function definition but not yet told the computer about the definition. We have not yet loaded the function definition in Emacs. Installing a function is the process that tells the Lisp interpreter the definition of the function. Installation is described in the next section. Okay, so if you didn't follow that, basically, I think it was pretty clear. Install a function definition. If you are reading this inside of info in Emacs, you can try out the multiply by 7 function by first evaluating the function definition and then evaluating multiply by 3. Multiply by 7, 3. Copy of the function definition follows. Place the cursor after the last parentheses of the function definition and type Control-X, Control-E. When you do this, multiply by 7 will appear in the echo area. What this means is that when a function definition is evaluated, the value it returns is the name of the defined function. At the same time, this action installs the function definition. By evaluating this definition, or defined function, you have just installed multiply by 7 in Emacs. The function is now just as much a part of Emacs as forward word or any other editing function you use. Multiply by 7 will stay installed until you quit Emacs. To reload code automatically whenever you start Emacs, see installing code permanently. Okay, the effects of installation. You can see the effect of installing multiply by 7 by evaluating the following sample. Place the cursor after the following expression and type Control-X, Control-E. The number 21 will appear in the echo area. Now if I run this, I should get 21. Yep. If you can read the documentation for the function by typing Control-H, Control-F, describe function, and then the name of the function, multiply by 7. When you do this, a help window will appear on your screen that says multiply by 7 is a Lisp function, multiply by 7 number, multiply number by 7. To return to a single window on your screen, type Control-X1. Change a function definition. If you want to change the code in multiply by 7, just rewrite it. To install the new version in place of the old one, evaluate the function definition again. This is how you modify code in Emacs. It is very simple. As an example, you can change the multiply by 7 function to add the number to itself 7 times instead of multiplying the number by 7. It produces the same answer, but by a different path. At the same time, we will add a comment to the code. A comment is text that the Lisp interpreter ignores, but that a human reader may find useful or enlightening. A comment is that this is the second version. Comment follows a semicolon. In Lisp, everything on a line that follows a semicolon is a comment. The end of the line is the end of the comment. To stretch a comment over 2 or more lines, begin each line with a semicolon. See beginning a .emacs file and see comments elisp for more about comments. You can install this version of the multiply by 7 function by evaluating it in the same way you evaluated the first function. Place the cursor after the last parenthesis and type Control-X, Control-E. In summary, this is how you write code in Emacs Lisp. You write a function, install it, test it, and then make fixes or enhancements and install it again. How you guys holding up? We got this. We got this. I think I've given the stream the wrong number though. I just realized. Yeah, it should be 4. Live number 4. Okay. You make a function interactive by placing a list that begins with the special form interactive immediately after the documentation. A user can invoke an interactive function by typing meta_x and then the name of the function, or by typing the keys to which it is bound, for example by typing Control-N for next line or Control-X for mark whole buffer. Oh yeah, okay. Interestingly, when you call an interactive function interactively, the value returned is not automatically displayed in the echo area. This is because you often call an interactive function for its side effects, such as moving forward by a word or line, and not for the value returned. If the returned value were displayed in the echo area each time you typed a key, it would be very distracting. So what it's saying there is, when we go forward a line, that's calling an interactive function. And if every single time we went forward a line, it had to give us the value that returns, and be really weird. Does that apply when you call it from meta_x? Yeah. Yep, it does. Okay. So an interactive multiply by 7, an overview. Both the use of the special form interactive and one way to display a value in the echo area can be illustrated by creating an interactive version of multiply by 7. So here is the code. Define function multiply by 7 number, multiply number by 7, interactive p, message, the result is the times 7 number. You can install this, the name of the function will appear in the echo area. Then you can use this code by typing Control-U and a number, and then typing meta_x multiply by 7 and pressing return. The phrase the result is followed by the product will appear in the echo area. So I'm actually not going to do it like that. I'm going to type it out because I need to get used to typing out a function definition. So first I do defun, then I do the name of the function, then I name my argument, and I give it like an explanation. So multiply numeric argument by 7, interactive and call that P apparently. And then I say message. So this is what the actual body. The result is D. And then I give it the argument 7 number. And then I evaluate this, and then that gives me multiple by 7, which is not what I want. I want multiply by 7. So that I can do Control U and like a number, and then call multiply by 7 with meta x, and then that gives me 7 times Oh, bugger. Okay, so if anybody's still watching, I apologize. Looks like my mute button accidentally got enabled, so I don't know how long I was talking to myself. But nobody watches these things anyway. Although I did notice that somebody joined the stream at one point, and they may have left so quickly because of the endless silence as I was talking and talking. Anyway, helps me talk through what I'm trying to figure out, so that's okay. Anyway, if anybody did tag along, thanks so much for coming along this long journey with me. I will talk to you guys later today. Peace. Oh, bugger. Okay, so if anybody's still watching, I apologize. Looks like my mute button accidentally got enabled, so I don't know how I'm talking to myself. But nobody watches these things anyway. Although I did notice that somebody joined this at one point, and they may have left so quickly because of the endless silence as I was talking. And anyway, helps me talk through what I'm trying to figure out, so that's okay. Anyway, if anybody did tag along, coming along this long journey with me, I will talk to you guys later today. Peace.